Hi, I'm Paul. This is Science That Sticks, and yeah, some reactions are reversible. A lot of reactions you can get back to their original substances, original elements, and so on. Not very easily sometimes, but there are some reactions that will have a forwards direction and a backwards direction. We call these reversible reactions. The most common that's ever described at GCSE happens to be the formation of ammonia. Now, you will notice a couple of things. Firstly, they're all gases. Two, instead of having an arrow, I've drawn this little bad boy here. It's a double-sided arrow. It means that there is a forwards direction and there is a reverse direction, a backwards direction. What does that mean? That means that when the reaction is actually taking place, the nitrogen molecules and the hydrogen molecules collide and they form ammonia. But the ammonia breaks down back into hydrogen and nitrogen molecules. That's the first part of it. Going from here to there requires a catalyst. It's an ion catalyst. It requires a high temperature. It requires quite a high pressure as well. We'll explore these in some more detail when I talk about Le Chatelier's principle in another video. Now, when we're looking at this, you've got to think to yourself, right, this is reactant A, this is reactant B, and this is product C. Okay? You could also look at it from the other way around. This is the product C, and it's making reactant B and reactant A. It's a two-way street. Okay? Now, when something is at dynamic equilibrium, that means that the rate, the speed at which these are reacting and changing into this is exactly the same as this is reacting and changing into these. The speed is exactly the same. Now, when something has reached that point, from a student's point of view, it's very difficult to sort of like, well, how do you know when the reaction's finished? Well, you don't. What you can do is you can start to remove the product if you so desire, and if you've got the capability to do so. Now, in this case, this is an industrial process, and for advanced students, you're asked lots of questions about this all of the time. And if you're doing A-level chemistry, it's definitely going to be showing up in some form or another. Now, at equilibrium, because the reactants are being made into products and the products are being made into reactants simultaneously, you need to observe something known as the position of equilibrium. In other words, do you have more products than reactants at this point in dynamic equilibrium, or do you have more reactants than products? It is possible to manipulate this, and for that we need Le Chatelier's principle. That's another video, I don't think. Till next time, stay cool. Bye-bye.